Hello there, I am Dr CN Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. I want to welcome you once again to my channel. We are going to continue in our series on set theory. And for this time, we're going to look at one example of solving problem with 3 sets. So for now and in coming videos, we are going to look at solving problems with 3 sets so that in the end, we are going to master and gain some confidence in solving problems with 3 sets. Let's look at what we have on the board. It's a straightforward question just for the purpose of illustration. Here we have, let's set A be 1, 4, and 5, and set B having 2, 3, 4, and 5, and set C having 4, 6, and 7. So we're told to show this in a Venn diagram. So where I'm going to write solution here, just you're seeing this, I'm going to draw a Venn diagram here to guide what I'm going to be doing. So we have a set A, and then we have set B, and then we have set C. So let's label it set A, set B, and set C. So we are told to illustrate this in a Venn diagram. The first area that we have to sort out in set problem is this point, this area. That is the intersection of the 3 sets. Intersection of the 3 sets. This one. Once we solve this problem, we can now solve this and this and this before we go to what is in at the end of at the ones that are the only unique to insert. So to solve this area is A intersection B intersection C. And then let's look at what is common amongst the 3 sets. Now for what we have, you see we have A, B, and C. And from this, can you identify what is common amongst them? What's common? Can you see that? Figure what? Or number 4. So you see that 4 is here, 4 is here, and 4 is here. So you see that 4 is common to all 3 sets. So A intersection B intersection C will be 4. So quickly we are going to enter 4 in here. We are going to enter 4 in here. Now we want to find what will be here. What will be here? What is here is A intersection B and not C. A intersection B and not C. That's A and B only. That's A and B only. So an A and B only will be A intersection B minus A intersection B intersection C. I want to invite you to go and check the video on 3 sets, dealing with 3 sets, operations and notations, so that these symbols that we're using with sets will not be strange to you. Please go back to that video and check on how we identify the different sections of 3 sets so that you will not be lost in the way what we'll be doing. So now what is A intersection B? A intersection B, first of all, we have A and B. What is common in A and B? Can you see that? What's common in A and B? 4 and 5. So this is 4 and 5. Okay, so we have 4 and 5 is common, minus A intersection B intersection C, that will be what? 4. Okay. So if we have 4 and 5, if we remove 4 from it, what will be left? We'll be left with 5. So to have A and B only, and we're going to put 5 here. So 5 will be here. We're solving it. I trust you're following. So we must deal with this before we go to this. Now, let's now deal with this. This one. This one is A intersection C minus B. That's A and C only. That will be A intersection C minus A intersection B intersection C. And how do we solve that? Now let's look for A intersection C. And what's common between A and C? What is common between A and C? A is 1, 4, 5. This is 4. What's common? 4 is common. So 4 is here and 4 is here. So 4 is the only element. And minus A intersection B intersection C is 4. So 4. So if we have 4 minus 4, what will be left? Nothing. So there will be nothing placed in this section. I trust you're following? Good. So this is a null set. So this is going to give us 5, as you can see. This is going to give us a null. So A, B, intersection C minus A, that is B and C only. B and C only will be B intersection C minus A intersection B intersection C. And B intersection C, what's common between B and C? Can you identify what's common between B and C? What's common? 4 is common. There's 4 here and there's 4 here. Alright, so this is also 4. This is also 4. And then this is 4 as well. So we're left with an empty. So nothing will be placed here. So nothing is here and nothing is here. Now, how do we now know what to be A only? Okay, A only. For A only, for A, look at A up here. We've already taken 4 and 5 out of A. It's already taken. Now we've taken 4 and 5. What's now left in A? What's left? 1. 1 is A, so 1. So 1 will be in A only. We've already taken that. So A only, ordinarily A only, will be A minus A intersection B minus C minus A intersection C minus B, that's A and C only, minus A intersection B intersection C. So that's what we have. So if you remove all these elements, we're left with 1, and then the element we're left with is just 1. Okay, so because we have removed 4 and 5 is already taken, we're now left with 1. So B only, let's sort out B only. B only. Now look at B. 4 and 5 have also been taken out of B. So this is B, this is B. Now 4 and 5 have been taken. What are we left with? 4 and 5 have been taken. What are we left with? We're left with 2 and 3. 2 and 3. So 2 and 3 will be here. 2 and 3 will come in here. So B only actually is B minus A intersection B minus C minus B intersection C minus A minus A intersection B intersection C. And then we're left with what? 2 and 3. So that's what we have, 2 and 3. Okay, the next one is here. The next one is C only, so C only. How do we How do we get C only? Now, C only, look at C. For C, only 4 have been taken. For C, only 4 have been taken. So now, let's now say only 4 have been taken, nothing here and nothing here. So let's come up to C. Are you following me? Let's come up to C. C, 4 have been taken, so we're left with 6 and 7. 6 and 7. So we're going to now write 6 and 7 in here. So C only will be C minus A intersection C minus B minus B intersection C minus A minus A intersection B intersection C. Whatever is there, and what we are left with is 6 and 7. So this is the Venn diagram, and this is how the solution should look like. Thank you very much for joining me on this video. Please go through this again. This is just a simple illustration of how you can represent listed items in a set in a Venn diagram, and how you can solve the problem. Remember, you must sort out the intersection first before you migrate into other areas. Before we go, let me check out something. Now, if we have before we go, let's have A union B. A union B is we put the values here, the elements here and the elements here into one. A union B will be 1, 2, 3, 4, and 5. And how many are they? There are 5 elements. Okay, there are 5 elements. And can you see the 5 elements? A union B, 1, 2, 3, 4, 5. So this is A union B. All of in here is A union B. The same thing if you want to have A union C. A union C, A union C will be 1, 4, 1, 4, 5, 6, and 7. Okay, so 1, 4, 5, 6, and 7. Okay, can you see it? And how many are there? 1, 2, 3, 4, 5. There are 5 elements there. So where is A union C? Can you see it? Look at 1, 4, 5, 6, and 7. See, they are all here. 1, 4, 5, 6, and 7. B has been taken out, even though it has B, but 1, 4, 5, 6, and 7. Lastly, we have B union C. B union C is pulling these 2 elements together. You have, what do you have? You have 2, 3, 4, 5, 6, and 7. And how many are there? 1, 2, 3, 4, 5, 6, or 6 elements. So B union C, look at them. B union C, all of this 2, 3, 4, 5, 6, and 7. They're all here. So you see that it's quite easy to manipulate set theory, especially if you know what to do. I want to encourage you, please, please, and please go and check out the earlier video we had put up on notations and operations of set, and go over this video again. And please do not forget to like this video and subscribe to this channel. God bless you.